The equation of motion, how does it really works, and we are hereby to prove it out in this video. But before you're able to understand the equation of motion, you need to understand a fact, the meaning of speed, the meaning of the unit of the speed. You need to understand velocity, and you need to understand acceleration. These three terms are highly important in equation of motion, about the proving, about everything that really concerns it. Remember, a speed is defined as the rate of change of distance with time. An average speed is also the distance over time. So, and there's a little difference between the speed and the velocity, because velocity defined as the rate of change of distance move with the time in a specific direction. It is also defined as the rate of change of displacement with time. Displacement means distance traveled in a specific direction. So let's go further to this and get exactly what we need to know. Now, speed is defined as the rate of change of distance with time. Average speed is distance over time, which is change in distance to divide change in time. So we have average speed, which is final distance minus initial distance to define final time minus initial time. So the average speed formula, it is distance over time, and the x represents the distance, while the t represents the time. Now the SI unit for the speed is meter per seconds. Now before we start the proving of equation of motion, let's try to explain some example that will give us the proper way of this. Let's see the example 1. A student walk a distance of 3 kilometers in 20 minutes. Calculate his average speed. Now, and the average speed, from what you're able to see here, average speed is the distance to divide time. But there's something you must put in place from the given values. We have been given the distance to give us 3 kilometers. As I've said earlier, the SI unit of the speed is meter per seconds or kilometer per hour. These are the two things, but let's go for meter per seconds. If you are not going for meter per seconds, what you need to do is that you convert the kilometer to meter. So 1 kilometer, 1 kilo is equal to 1,000 of a meter. So it will now be 3 times 1,000 meter. So our distance, which is x, will give us 3,000 meter. So that is our distance, and our time here, we have to convert to 20 to seconds. We have 20 minutes. Now in 20 minutes converting to seconds, it will just give you, so the time will be 20 times 60 seconds, because 1 minute is 60 seconds. So our time from this angle will give us 1,200 seconds. So that is the time. Now I say calculate the average speed. As we have known, our average speed at this angle, the average speed, as we all know, that it is distance over time, and our distance is 3,000 meters, to divide the time, which is 1,200 seconds. So this, we cancel this. It will remain 30 meters to divide 12 seconds. So by the time we have 6 here, we have 5 meters over 2 seconds. That is so let's try to put, you have 2.5 meter per second. So that is the value for there's the first example in speed. So we still have to continue from this. This is example 2. A driver traveling at speed of 115 km per hour received a text message on his mobile phone. How far is he in kilometer 20 seconds later from when he received the text message? Now, we have to write out the given values. From the question given to us, we were given speed. Our speed is 115 km per hour. And we are given time. Our time to have 20 seconds. But I have tried to let you understand a fact that the unit for speed is meter per seconds or kilometer per hour. You have to consider these two very well. Therefore, the 20 seconds will be, you all know that 60 seconds make 1 minute and 60 minutes make 1 hour. So our 20 seconds will be in the forms of 20 over the first 60 seconds to multiply the second 60 minutes, which will give, so this one will be written in hour. Now, you all know that if speed is equal to distance over time, and the question says that how far is he in kilometer later from when he received the text message. So we need distance to be speed to multiply time. So if our x is equal to, and our speed is 115 kilometer over 1 hour, to multiply 20 time to divide 60 by 60 in hour. Now the hour we cancel hour, that is just the meaning. So our speed will be 115 kilometer to multiply 20 over 60 times 60, which will give us, so 115 times 20 over 60 times 60. So by the time we divide the both sides, you know, we still have one unit, which is a kilometer. So we have 0.64 kilometer or 0.639 kilometer. Sorry for that, 0.4. When you use calculator, you will get this 0.39 kilometer. So that is just the meaning of calculation involving speed. Let's now try to explain the definitions of velocity and acceleration before we now go to the equation of motion. There is a uniform speed if the speed is constant throughout the journey. The speed v is said to be uniform, for the v is equal to distance over time, that is x over t. So now we see continue that velocity is speed measured in a given direction. It is therefore a vector quantity. That is part of the question that they do ask in physics question, no matter the types of the exam. We still continue to have acceleration. Those are the terms we must know before we start proving of the equation of motion. Acceleration A is the rate of change of velocity with time. Therefore, A is velocity over time. And the SI unit of acceleration is meter per second square. You must take note of this. But when the acceleration is now moving in a constant, if the rate of change of velocity with time is constant, as means the acceleration is moving constant, it has no break, it's still moving like that. That's why I say it's constant. The acceleration is said to be uniform. For example, it moves like this. This is uniform. It starts and continue moving. So it does not change. Coming down, go up, coming down, go. So at this part of that, the acceleration is said to be uniform. So the formula for that acceleration is V over T, which is constant. If the velocity of the body is increasing with time, it's said to be accelerating. But if the velocity of the body is decreasing, if this one is increasing, you talk about the body is accelerating. But if the velocity of the body is decreasing with time, the body is said to be expressing retardation or deceleration. In this case, acceleration is negative. So now we are now going to the equation of the motion. So let's go to the first equation of motion. In the first equation of motion, which if a body at rest is already moving with the initial velocity u meter per second, begins to accelerate at a meter per second scale, after a particular time t, it will obtain a final velocity. So this is exactly where we are going to start proving. So after it is able to attain a final velocity, and you all know that acceleration is change in velocity to divide time interval. So now I'm telling you that acceleration, let's put it here, acceleration cannot be written as final velocity minus initial velocity to divide time interval. Now in these two, the time interval, therefore our A will now be the final velocity from what you have said earlier, will give you V minus initial velocity to give us T. Now at this point in time, let's apply some little mathematics to have V minus U is equal to AT. Let's try to make V as a subject of the formula. To have V is equal to, this U will become plus U plus AT. So therefore the V will now be equal to U plus AT. So if V is equal to U plus AT, this telling you that this is the first equation of motion. The first equation of motion. So stay tuned to continue with the next video, which will talk about the second equation of motion, the third equation of motion, and whereby we are going to start a very good example in calculation in physics.